The F5 Local Traffic Manager, NAT and SNAT Concepts. We're going to talk about some of the translation and things that we do to actually get traffic flowing a little bit differently through my F5. So we've seen that virtual servers already translate addresses for us by virtue of what they do. They're load balancing. They already do things hiding the client. The clients over here don't see the specific servers. They just see one address right here. Okay, so they're referred to though as a one-to-many type object. Now, SNAT or SNAT, I guess depending on how you want to pronounce it, is a secure NAT because actually it refuses any traffic coming inbound. Okay, so anything from the clients coming to an SNAT or a SNAT address, not going to happen. So nothing uninvited is going to be allowed on there. It's more like an outbound source NAT. So it's for these guys behind here in order to get out. So say to the internet, maybe they have to do updates or anything along those lines. So look about it from a thought process of the F5, the responses, so things that come back, are actually having their destination address translated. So this is a many-to-one type object. Now NAT, on the other hand, is really very simple and straightforward. It's one-to-one. These are going to be very simple things for as far as like if I want to from the internet or from a DMZ or something, I want to actually manage the individual servers over here. I will need to be able to address them on a one-by-one basis. Either I have a backdoor route to get to it, or I'll do NAT through my load balancer. Now, NAT and SNAT are not load balancing objects. Okay? So NAT and SNAT are, and virtual servers for that matter, are not mutually exclusive either. So as one example, a virtual server can translate a destination address. Okay? That's what it does. And at the same time, SNAT will change the source address within the same type of flow, the same type of connection idea. So we're all done, right? Less than, I guess 2 minutes or so, and we understand that. No problem. Well, not quite that simple. So let's think about this from the point of view of our device. So how does a normal connection take place over here? So I go from the client into a virtual server address. I have my pool, pool members and over here that I'm going to translate everything to, and so it'll get to the servers on the other side. So all the translation takes place right here in the middle, all that's taken place for it. So what about if my server wants to go out? Not necessarily the client, but we'll say to the big I out here, the big internet. Well, I have to have some object in place in order for that to occur. Like I said, either there's some other router over here that they're all configured to be able to go to that way, although that's really not a good idea because default gateway should be my F5 right here. But you may have specific routes for Windows Update or a Linux distro site or whatever your servers happen to be. So maybe you have that going on. But if not, tuning everything towards your F5 right here, we're going to have a process in place to actually make that occur. So default gateway, put a DG right here for default gateway, is the best way of doing things to assure that all of my servers are going to connect with and deal with my clients properly no matter what their IP address happens to be. At the same time, again, if they want to go out to that big I over here, then I'm going to have an SNAT object in order for all of those sources to translate on the way out. And that may be just, again, some IP address that exists right here. It may not be my normal virtual servers that come in, but some IP address over here that allows outbound connections out to the internet. Now, that's our objects. It is not going to be a load balancing object, but it is something that has to be configured. Likewise, if I want to manage, so we'll say management right here, and do NAT. NAT is going to be a one-to-one, and could be a bidirectional thing. So if I've got it set up for each server, then I'm perfectly good to go that way. But I may need some firewall or something else over here to make sure that nobody else other than the authorized people can get in to manage those servers directly. For most part, we try to hide, if you will, but we try to put all of our servers behind these virtual server addresses. That's all the rest of the world should see. Management may come in for a different interface over here. So keep in mind, from a design perspective, doing management directly through there from the internet anyway may really not be a great idea to do. Connections are traveling through the ADC, but they are not tracked if they're NAT. They are also not load balanced. So to be functional, to actually work, NAT must be enabled for the VLANs. Okay, so what do we have over here? We had VLAN 210. So I would have to go in there and actually enable NAT on that portion, and also from the side, so 201 over here, from the side where traffic is destined to go to or come from. This might be useful as far as like I said, out-of-band management for the individual servers, but because it does support the initiation of traffic in both directions, it does present a security problem. So watch that. Now, SNAT, on the other hand, is going to be outbound. So I suppose we can draw arrows both directions on here. But SNAT, notice, is going to be an outbound direction only. So pool of devices, and it may be a one-to-one if you actually do it that way, but generally speaking, it's kind of like doing port address translation on a router. So stuff you've been through before shouldn't be all that bad for it. They are unidirectional in nature. Well, obviously they allow the responses, but coming from the internet, I can't initiate traffic to an SNAT pool. It's not going to allow me to do that. So it only allows connections from the pool to go out, and then the appropriate responses coming back. So these things are typically allowed. My internal pools very often are RFC 1918 addresses. Okay, so my private addresses internally, which makes the most sense, but it allows these to connect to the internet for updates or things like that, patches or whatever they have going on. The internal servers, on the other hand, will remain hidden, and now the ADC will actually own the connection. So it kind of handles everything and deals with it in there. So once I start doing this, when I get my SNAT configuration in place, these are going to be configured again, kind of with a pool. So, and it may be a different pool, maybe a larger pool than the pools that I use for my virtual servers, so they don't have to be the same thing, but I do still have to create a pool for it as far as what the allowed hosts are going to be. So, like I said, they could be one-to-one if you only have one device in the pool here, or all-to-one, or some-to-one, or whatever, depending on your configuration. So SNAT may also overlap with a virtual server IP. So remember, it is unidirectional only, so it's only going to be outbound. So if I have a limited number of IP addresses here on the outside of my my ADC, that may be a great way to do it, is utilize, so what I had 101, 102, 103 down here, to utilize one of those addresses for doing that outbound overload type translation. Okay. So sources for SNAT could come from a static address, so something bound directly on the box, a floating address at that point, an address from an SNAT pool, so I can have a rotation of addresses, or what we call an automap address. So automap addresses are a little bit different, and we'll go into that in just a second here. Also, as we get further on, we could use iRules for more policy-based definitions on, this server for this type of traffic goes out 103. These three middle servers here will go out 102. And this end guy, only if he's going to, say Microsoft or something, goes out 101, for everything else goes out 102. We can get all sorts of granularity in terms of those rules. But basically, it's PAT. Okay, so it's port address translation. So when looking for my pool of addresses in there, we talked a little bit about the automap. Okay, so automap is a method of selecting it as well. And what's going to happen on automap is basically you let the F5 decide how things are going to be mapped or where they're going to go. Now, it'll automatically select one of the self-IP addresses. Now, typically this will be a floating IP address, because that way, failover or HA can actually take care of it. But it's going to be one of the ones from the egress VLAN, so whichever way it's going to go. Now you got to keep in mind that with this, with all of this in general, routing has to occur first. Okay, because I may have multiple interfaces, so I have an interface down here and one out to the internet and one, wherever else I'm going. I have to determine where, as the packet comes in, where's it supposed to go before I really determine how or if it's going to get translated. So kind of watch for that perspective, but that way we figure out what that proper translation is going to be, and obviously the return path as well. Hopefully things will all make sense that way in terms of how our network is set up. So the SNAT pool really holds all of the possible end results as far as whether something's going to work or not. But once I get my egress port translated on there, AutoMap is going to pick which of the floating IPs are going to be available for it. So really, from a destination standpoint, I don't have to put anything. I just check AutoMap as far as being allowed. If I'm creating a pool, whether it be a pool of many addresses or a pool of one address, then I've got control over how that's going to be going in there. Now, when I start looking at this from having multiple floating IP addresses in a pool, then really what's going to be happen is that one of those addresses will get used until all 65,535. 65,535 ports are used up. Then it will rotate to the next IP address, then it'll rotate to the next one, so on and so forth, and it'll loop back up to the top. Okay? So floating addresses are always going to be used before interface addresses. So, and really that's from my AutoMap perspective as well. So I could use the actual self IP, the local only one that's designated right there, but anything I have for floating will take place first because, like I said, high availability. We want the stuff to be actually put on there. So all these things that we have going on, kind of good to be paying attention to on there. Now, from an order of processing, so we kind of keep things in mind here, since I said that we could use my virtual server address as the outbound address as well for things. Requests for traffic, so virtual servers are actually going to get processed before the SNATs are. Next, the SNATs are going to be applied based on how specific the network mask is within the origin field of where we're going in the configuration. There may be overlaps, depending on how many different things you have set up. So like I said, I could do all of my servers here. I could do 2 of the servers right here. So the most specific thing is always going to win, just like in routing. So kind of keep that part in mind for it. But otherwise, those are the basics, mostly of the SNAT, because NAT's a very simple portion. But those are the basics of how I do both NAT and SNAT for my configuration. So next, we'll be able to see how we actually do them on the device itself. I hope this has been informative for you, and I'd like to thank you for viewing.